Good morning, students. I'm sorry I couldn't be there today to explain to you how to add, subtract, multiply, and divide functions, as well as find the composition of functions. So I'm going to try and give you a quick video so that you can work on your homework. First of all, what you will see, let me find my little pointer here, right? Here we go. Here is the notation for composition of functions and adding, subtracting, multiplying, and dividing functions. You see, if you're going to add two functions, it can be written like this or like this. If you're subtracting, like this or like this. If you're multiplying, and notice this is a solid filled dot, like this or like this. If you're dividing, it can be written like this or like this. Now I will tell you that when you're adding, subtracting, multiplying, and dividing functions, it is just as easy as adding, subtracting, multiplying, and dividing. Now, however, if we are finding the composition of functions, that's a little bit different. And the notation to write that is seen right here. So you'll see that it's a dot, but it's not filled in. That means composition of functions. Another way to write it is I have the g of x function inside the f of x function. So really what a composition of function is a function inside of a function. All right, and this is the one that's a little bit more complicated. If it's written with the g first, the little circle, and then the f, the g is on the outside, the f of x is in the inside. So let's go through a few examples. If we go down here to the bottom of the page in our notes, we've got our first example, f of 1 plus g of 2. This is as easy as finding f of 1, which we learned last week, and we're going to add it to g of 2. So first of all, let's find f of 1. So we're going to put 1 in place of x in the f function. So 3 times 1 minus 2, this equals 1. Now we need to find g of 2. So we're going to put 2 in the g function, which is 2 squared, and that gives us 4. Now all we're doing is adding f of 1 plus g of 2, and that gives us 1 plus 4 equals 5. And that is our final answer. So let's go on to example B. This is a little bit more interesting. This is f times g of x. And what we're doing when we do this one is we're taking f of x and we're going to multiply it by g of x. All right? So here's f of x. And we're going to multiply it by g of x. Now you can actually simplify this by using the distributive property. So we would have 3x to the third minus 2x squared. And that's all that we are doing. We simply multiplied two functions. So let's go down here and we're going to do a composition of functions. So this one has the g inside of the f function. Whoops, let me get the functions on the screen here. So let's go ahead. We need to find g of 5. You're always going to start by finding the innermost function first. So here's what we're going to do. We're going to find g of 5, and that equals 5 squared, which equals 25. So now what we are doing is we're taking this 25 and we're going to put it inside the f function. So we are really looking for f of g of 5 equals f of 25. And that's going to equal 3 times 25 minus 2, and I think that gives us 73. Okay, the next function is written with an open circle. That's not multiply, that's going to be a composition of functions. Let's write it with a function inside of it. I think it's easier to do this way. So here's what we've got. We've got g of f of 3. All right, so the first thing we need to do is find f of 3. And this is going to be 3 times 3 minus 2 equals 7. So what we're trying to find, if we're trying to find g of f of 3, we're really looking for g of 7, which equals 7 squared, which equals 49. The last one we've got a function inside of itself. And really, you're going to do this the same exact way. So this is f of x. All right? So first thing, we're not finding a number here. We're finding f of x. What that means is we are going to take f of x and put it inside f of x. So really, what we're trying to find is f of 3x minus 2. And what this means for us is we're going to put 3x minus 2 in place of x in the f function. So this is 3 times 3x minus 2 minus 2. And notice something. This in our function was just x. See? And what we put there was the whole 3x minus 2. So now what we've got to do is simplify and combine like terms. So we've got 3 times 3x is 9x minus 6 minus 2 gives us 9x minus 8. Okay, let's go from page 6 to page 7 of our notes. And we're going to go through a few more examples. So hopefully this becomes a little bit clearer to you, because I know this is probably something that you have not seen or done before. So our first example, example A here, we're finding g of f of 1. So the first thing we're going to do is find f of 1. So f of 1 is 3 times 1 minus 2 gives us 1. So now g of f of 1, we're just going to substitute. We know f of 1 equals 1. So equals g of 1, which equals 1 squared, which equals 1. All right, let's go on to B. We have f of 3. Always start with the inside, and let's find f of 3. So f of 3 equals 3 times 3 minus 2 equals 7. All right, so here's what we have. F of 3 equals f of 7, because the f of 3 equals 7. So now we're finding f of 7, and this equals 3 times 7 minus 2 gives us 19. All right, let's go on to C. In this one, we're kind of doing a couple of things. I've got an f of 3 inside the f function, but really it's 1 over. First thing I need to do, I need to know what f of 3 is. We already found f of 3. F of 3 was up here. It is 7. So here's what we're really finding. So this equals f of 1 over 7. All right, we replaced f of 3 with 7. So this is putting this into the f function. So this is 3 times 1/7 minus 2 gives us 3/7 minus, how about 14/7, because we need a common denominator, gives us negative 11/7. Okay, next one, D. We've got a lot of stuff going on inside here. All right, first of all, we need to find f of negative 1. So f of negative 1 equals 3 times negative 1 minus 2, which equals negative 5. So what this really equals is g of 2 times negative 5, which is negative 10. So we're going to be finding g of negative 10. This equals negative 10 squared, which equals positive 100. All right, let's go down below, and you might need to write down what these functions are, f of x and g of x, up here at the top, because they're going to float off the screen as we do this. Okay, now we have f of g of x plus 1. Now this one is going to be kind of busy, so let's go over here to letter f, f of g of x. And remember, g of x is just x squared. So what we can do is write this as f of x squared. Now what we're doing is we're putting x squared in place of x in the f function. So this equals 3 x squared minus 2. And what you notice, this used to be just an x, but because I'm finding f of x squared, it is now an x squared. All right, let's do this with h. We're just going to go in reverse. This is g of f of x. So let's rewrite this. Switch back to blue here. This is g of 3x minus 2, because f of x equals 3x minus 2. And we're just going to put 3x minus 2 in place of x in the g function. So this is going to equal 3x minus 2 quantity squared. Now, here's what you got to remember about this. You need to multiply this out, but you need to FOIL it, F-O-I-L, first, outer, inner, last. If it helps you, write it out twice. When you do that, you will get 9x squared. You'll have minus 6x, and minus 6x gives you minus 12x and plus 4. So access some Algebra 1 knowledge there. Let's go over to g, where we have g of x. Remember, g of x is x squared, so this is g of x squared. And now we're putting x squared in the g function. So this is going to equal x squared squared. Simplify that, we get x to the 4th. So g of x is x to the 4th. Now let's go back here for a second, and I feel like I'm going to need some more room to work on this one. Let's go back here to e. We've got f of g of x plus 1. So first of all, we need to find g of x plus 1. So g of x plus 1 equals x plus 1 quantity squared. Okay? And remember, you want to simplify this by using FOIL. So you're going to multiply x plus 1 times x plus 1, and you're going to use FOIL, and you're going to get x squared plus 2x plus 1. All right? That is what we're going to put inside of our f function. So what we're really finding is f of x squared plus 2x plus 1. So we're going to put all of this in our f function. So this is 3. Let's put it in here. X squared plus 2x plus 1, then minus 2. So what you're going to want to do is distribute that 3. So this is 3x squared plus 6x plus 3 minus 2. Combine your like terms, and we get 3x squared plus 6x plus 1 when we are all done. And I think let's go ahead and go down below here to the very last problem. And we're going to use our f function, and we're going to do some interesting things with it here. So first of all, we have an f of x plus h and an f of x, and we are subtracting them. All we're going to do is whatever is in here goes in the f function. So when we do that, we have 3 times x plus h minus 2 minus, now since you're subtracting the whole fraction, let's put it in brackets, And this is simply 3x minus 2. But it's important that it's in brackets because you're going to need to distribute this subtraction. So let's go ahead and simplify. We've got 3x plus 3h minus 2, distribute the negative, minus 3x, and then plus 2. And the interesting thing here is the minus 2 and the plus 2 will cancel to 0, and the 3x and the minus 3x will cancel to 0, and all you have left is 3h.